Now let's talk about the electrical circuit component. Since we already know about the difference between conductors and insulators, let's proceed to a system of conductors and components forming a complete path for a current to travel. So always remember that the electron flow is one of the most basic required component in order that the presence of current, okay, is observable. So the properties of an electrical circuit include: 1, voltage. Next, current, C-U-R-R-E-N-T. Next one, resistance. Okay? So we have to remember also, in this case, we need to know about the proper writing of unit. So the unit mainly for voltage, the properties already mentioned. So we have volts as unit. We can write also V, the shorthand technique. For current, we use amps or ampere. Okay? So this is for the current. Then for ohms, we use, okay, this one. Okay? This is for the resistance. So let's find out how to determine the current. What are the various indicators when we determine current? Current is the flow of electric charge measured in ampere or A. So we try to base another situations. For example, we have a water tank at home. Of course, it's connected with a pipe or pipeline. Of course, there is a storage, water storage. We expect that, of course, we have pipeline or a faucet. Right? So, let's continue. So when the faucet is off, what will happen? Take note, we have a tank that serves as a battery. For example, now we relate or based with other situation. Then the pipe stands for wiring component. Then our faucet will also be with switch on and off. Will also act, okay, with the presence either every time we switch on or off with a faucet component. Amen? So therefore, when the faucet or switch is off, is there any flow of current? Now the answer is no. We cannot see any pressure or the amount of water coming out. Means to say, in electricity, there is no electron flow. Okay? When the faucet switch is on, is there any flow of current? The answer there is yes. The answer is yes. There is definitely the flow of current. Okay? Every time we switch on our faucet, or even we switch on the lights. Okay, okay, you kindly switch on. Okay, if you kindly switch on the light, switch off the light. Now, okay, so it says that when we switch off the light, there is no current, right? Okay, if you go back again. Okay, so when the faucet is on, or when we are going to switch on, is there any flow of current in this fluorescent light? Okay, you kindly switch it on. Okay. All right. So So this definitely emphasizes that there is a flow of current because we were able to light up the fluorescents in our room. Okay? So when we switch off, there is a flow of current. When we switch off, there is no flow of current. Remember this. When we switch on, there is a flow of current. So, when the switch is off, there is no current. I'll repeat. When the switch is on, there is current. So, between the current flow, conventional current assumes the current flow out of the positive side of the battery through this circuit and back to the negative side of the battery. So, this was the conventional current. Okay? While the electron flow is what actually happens. Now, when the electron flows out with the negative side of the battery through the circuit. So in conventional current, always remember this application through engineering field or engineering study or application. They use conventional current, okay, connecting from positive terminal to negative terminal. While the electron flow, this is what actually happens. Okay, in which reverse. This is usually the application for most students who are studying in this kind of subject, about electromagnetism or electricity, principles of electricity. So for electron flow, started from positive, negative to positive terminal, and this application usually applied for most students. For the research purpose. They use schematic diagram, electrical schematic diagram. Next one. So the conventional current, electron flow are used in general science discipline, while conventional current applied in engineering courses. Now let's move to voltage. So the word voltage is pressure, a force. Okay, so the voltage are found in here. The amount of water present, when we are going to base about water. But this one emphasizes, our water tank, okay, stands for, this one, the role of this is a battery. So, there is a pipeline in which, okay, it also refers if the amount or the load of voltage is high. Of course, you expect that the current also is high. Okay? So, every time, it depends on the usage. So, this, the force or pressure that causes current to flow, measured in volts. Okay? So, when the faucet switch is off, is there any pressure or voltage? Now, yes. Pressure or voltage is pushing against the pipe, the tank, and the faucet, right? So when the faucet switch is on, is there any pressure or voltage? Okay, the answer is yes. So every time we switch on, the pressure is still present. Even if we switch off, the pressure is still present, okay? So it pushes the flow of current through the system. So this will be the emphasis. How we describe every time we switch on or off. Is there any pressure or voltage present? Yes. Based on the load capacity of the battery. So voltage in a circuit, remember, the battery provides voltage that will push current through the bulb when the switch is on. Right? Okay, what about resistance? The resistance is the opposition of current flow. So it used to oppose. Resistance act as a referee to moderate the flow of current. If the current is too high and fast, what will happen? Okay, it should have resistance to resist against the flow of electrons. So resistant act as a referee to moderate the flow of electrons. So this one measured in ohms. So this one emphasizes what happens to the flow of current if a rod gets lodged or blocked in the pipe. Okay, so sometimes you may experience that maybe there were sand particles that blocked the pipeline. So the possibility, our faucet, okay, the flow of water in our faucet, very slow. So, means to say that there is a resistance. There is something that holds or resists the flow of water or even the electrons, if you're going to base that one in electricity. Okay? So, the flow of current decreases. The flow of current decreases or slow down. So in this resistance in a circuit, resistors are very important components that create resistance. That is why our computer, laptops, iPad, our mobile phones, or our appliances at home, okay, there is an always attachment of resistors or diodes, okay, to avoid overloads or power outage as well, okay. So this will help to resist or control the flow of electrical energy once it is connected direct to the power of electricity. So there is something helps to resist or to slow down, in order to avoid accident and of course for safety purpose, right? So resistors helps to reduce the current, causes the bulb to become more thin. That is why there were times that our bulbs or other appliances, okay, may experience what we call slow brightness, or even it's in moderate some components, right? There's a moderate flow of energy, okay, which is quite different from when the higher current is present. Okay, so because the resistance helps to slow down or resist the energy flow of electricity. So we have different materials. We have multimeter. Instrument used to measure the properties of electrical circuit, including for voltage, we have voltmeter, for current, ammeter, for the resistance, ohmmeter. Okay? So those are the three important components that usually helps to measure about the loading capacity of electrical energy or electrical power. So by measuring the voltage, as you can see in here, measuring across a component, okay, we need to check the switch, the battery, the presence of resistors, and then the light, okay, this one. So this helps to measure the presence of, according to how much its voltage capacity. So there is a tester, that's what we call voltmeter. Then another one,